dear students. Today again I discuss about analytic geometry in 3D. Geometry 3D. So here discuss about today the a very important relation also, and the area of a triangle. Area of a triangle and a very important relation. So before starting this topic, I appeal to all of you. You have not subscribed this channel, then subscribe this channel to get such kind of videos. Subscribe this channel, and if you like, then like and share with your friends. And if you have anything to say, then comment me. Let's start. First, we establish a result that a square is equal to e1 square plus e2 square plus e3 square. So what does it mean? It means that in 3D, if we draw a triangle in 3D, if we draw a triangle, then the area of the triangle, uh, uh, that square of the area of the triangle is obtained by the sum of the square of the triangles, uh, which is made by the triangle on the coordinate planes. So what will be, this is the coordinate plan, and this is the projection of the area on the yz plan. This is the projection of the this area into the xz plan, and this is the projection of the area into uh, yz into xy plan. So in this way, the relation made that the all the projected areas of the triangles square, sum of the square is equal to the triangles area. So now we can establish this. Drawing a rectangular Cartesian coordinate. Take this each. There are three axes: x, y, z. Now if we make a triangle, if we draw a triangle, this is a triangle. I am taking this each. This is ABC. Now its direction cosines are considered the normal or the perpendicular on the on the triangle. So this is a perpendicular on the plane of the triangle. This is I am taking now. This is I am taking PQ. So PQ is perpendicular on the plane of the triangle. PQ. Now the direction cosine of this triangle are considered the direction cosine of this normal. Now if we take the projection of this triangle on the yz plane, then it will be like in this way, and I'm giving now A prime, B prime, and C prime. So now here it is the normal of the PQ is the normal of the triangle ABC, and this is the projection of the YZ plane of the triangle. So if it has direction cosines LMN, then then here if we take this projected triangles direction cosines is considered the normal on the plan. So I am taking the normal in this way. This is the normal on the projected area triangle. This is I am taking P prime Q prime. So now we wish to know the area of the projected triangle with respect to this area of the triangle. So the projected triangle's area, if it is denoted by A1, if it denoted by A1, then yeah, and this area is denoted by A, then the projection of the normal of PQ on the so this normal projection on the on this normal will be PQ will be uh, P prime P slash Q slash into L. This will be the projection of this normal to the normal P slash Q slash. So in this way, so the triangle's projection what will be? The triangle's projection A sorry I reverse this. It will be P prime P slash Q slash is equal to PQ into L. P slash Q slash will be actually PQ the projection of the PQ uh, multiply its direction cosine. So length of PQ and its direction cosine will give the projection of the normal of the projected triangle on the YZ plane. So the area will be the projected area on the YZ plane will be A into L. In the similar way, the other area if we will obtain is A1 actually. If we obtain A2, then it is this will be again A into M in the similar way, and A3 is also will be A into M. And then if we square uh, squares of both sides and add, then we will get A1 square plus E2 square plus A3 square is equal to A into A square into L square M square plus M square equal to 1. So we will obtain that this is equal to A square. So this is the important result, that of any triangle's area is square equal to the sum of the squares of the projected areas of the triangle on the coordinate planes. Now we'll use to find out the area of a triangle. How we can find out the area of a triangle? By coordinates of the vertices of the triangle, area of a triangle. Now we will use vertices of the triangle to find out the area of a triangle. So we will take 3 points A, B, C. If there is the coordinate planes and we are taking a triangle ABC, but the coordinates of ABC are, this is x1, this is y1, and this is z1. Coordinate of B point is x2, y2, and z2. And coordinate point of C point is x3, y3, and z3. Now, if we take that area of this triangle is delta, and uh, its coordinate planes, its projected areas of this triangle on the coordinate planes are delta 1 on the yz plane, delta 2 on the xz plane, and delta 3 on the xy plane. Then if we consider just only one projection, the yz plane, this is, so this will be the coordinate of the projected triangles. Coordinates will be, here will be the projected triangle A place, B slash, and C slash. So the coordinates of this triangle, so so this is the delta 1, and its coordinates will be A slash, coordinates will be there for all these 3 point vertices. X is 0, so we will take x is equal to 0. So for A point, this will be 0, y1, z1, for is b slash, this will be 0 y2 z2, and for c slash this will be 0 y3 z3. Now we can calculate the angle with the three vertices, uh, because if you take this yz is just a plane, it's a plane, it is not a 3D. You can omit this x plane, x axis, then you will get just yz plane, and in a simple plane our area is defined. So what will be the area on the yz plane of that projected triangle? This will be equal to, this will be equal to delta 1. We know from the analytic geometry 2D that this will be equal to 1 by 2 in the determinant form. This will be y1 y2 y3 z1 z2 z3, and this will be 1 1 1. So in the similar way, all the all delta 2 and delta 3 can be obtained. The similar way, all the projected triangles on the Cartesian Cartesian plan can be obtained by taking one the rectangular Cartesian coordinate, just a simple coordinate plan, just uh, omitting a axis from the rectangular coordinate plan, and in this way projected triangles area can be easily obtained. Now if we use this result in the formal result, where delta square is equal to delta 1 square plus delta 2 square plus delta 3 square, then if we put these values of delta 1, delta 2, delta 3, we will get 1 by 4 determinant of y1 y2 y3 z1 z2 z3 1 1 1. This is square, and again we will get for delta 2 1 by 4. Here y is 0, so this will be x1 x2 x3 z1 z2 z3 1 1 1. This is square plus 1 by 4 into here z is 0, so this will be x1 x2 x3, and this will be y1 y2 y3, this will be 1 1 1, and this is square. This is our area of the triangle, and we have found out this formula we can use to find out any and area of a triangle in the 3D. Thanks for watching.